and the title is Area and Circumference. And circumference is the distance around the outer edge of a circle. Circumference is the distance around the outer edge of a circle. So there's a circle. So if you start here and then walk all the way around the outer edge, the distance it is all the way around, that's called the circumference. Okay, then a radius is a line from the center of the circle to the outer edge. Radius is a line segment from the center to the outer edge. So here's the center of the circle right here. I'm talking about the exact center. Then if you draw a line that goes from there out to the edge, it doesn't matter which way you go, that's called a radius. Okay? And then a chord is a line segment connecting 2 points on the outer edge. A chord is a line segment connecting 2 points on the outer edge. So let's pick maybe this point and that point on the outer edge of the circle. And then if you connect those, that's called a chord. So I've got a line segment here that's connecting 2 points on the outer edge. The term for that is chord. Okay, and then the diameter is a line, a chord that goes through the center of the circle. Diameter is a chord that goes through the center of the circle. So this is just a regular old chord because it's connecting 2 points. But sometimes a chord like this one, so a chord connects 2 points on the edge of the circle. So this is a chord. But here's another chord because it's connecting 2 points on the edge of the circle. And this one happens to go through the center. So it's a special chord that's called a diameter. So here's just a regular old chord. Here's a chord that's also called a diameter. Okay, and of course, the diameter is twice as big as the radius. Because here's a radius and here's another radius. So the diameter is twice as big as the radius. So there's a formula for diameter. It's 2 times the radius. And there's also a formula for circumference. So if you're trying to measure how far it is around the edge of the circle, that's called circumference. And you can figure that out by taking 2 times pi times the radius. So it's actually kind of amazing that this number that goes on forever is involved with measuring how far it is around the edge of a circle. It's kind of strange that that crazy number gets involved with measuring that. But it does. So if you take 2 times that crazy number times the length of the radius, it'll tell you how far it is around there, the circumference. And pi also gets involved with the area. To find the area, it's pi times radius squared. And those formulas are pretty similar. They both have pi's in them, they both have r's in them, and they both have 2's in them. The difference is here the 2 is multiplied, and here the 2 is squared from the r. But they look kind of similar, so it's easy to get them mixed up. Okay, I think that's everything on 66, which just let me double check here. Yep. All right, so then the second one is number 67. And the title there is Angles and Arcs. And an arc is a part of the outer edge of a circle. An arc is a part of the outer edge of a circle. So here's the entire circle. But if you had a point here, let's call it B, and a point here, let's call it A. If you looked at just this curved piece here, so just that part of it, so not the entire curve, but just that bit of the curve, that's called an arc. So an arc is a part of the outer edge of a circle. And when you name it, you use the 2 letters, so B and A, and then you put a little curved line on top of it. So BA is the name of that arc. And we've done stuff like that before. Like sometimes we put down BA with a straight line on top of it. So that's the name of a line segment. Like if you connect it from there to there. But this is the name of the curved part. So there's a difference between this straight line and this curved line. So that's an arc, and that's a line segment. This is old stuff, this is new stuff. Okay, so that's called an arc. Then there's also something called a semicircle. And a semicircle is an arc that is half a circle. So if I put D way over here, and I went from B to D, that would be an arc, because it's part of a circle, but it's also half the way around, so it's called a semicircle. So in the picture, BD is an arc, and it happens to be half a circle, so it's a special arc called a semicircle. Okay, then there's minor arc. And a minor arc is an arc that is smaller than a semicircle. A minor arc is an arc that is smaller than a semicircle. So BA was a minor arc because it's less than a semicircle. So today we're shifting topics. We've been talking about triangles a lot recently. And today we're shifting, and the next topic is circles. Obviously we've been talking about circles today. So that's what the next section is about. There's a lot of vocabulary today. When you do a new unit, there's generally vocabulary to start out. So that's why there's so much vocabulary. Sorry about that. Just a couple more things. The next term is major arc. A major arc is an arc that is bigger than a semicircle. Major arc is an arc that is bigger than a semicircle. So if you went from B around this way to A, that would be a major arc because it's more than halfway. So if you went B to A that way, that's a minor arc. But if you go B to A this way, then that's a major arc. Now we need a way of saying that we're going to go this way instead of the short way. So what we do is we use 3 letters. So we're going to call this BDA. And that way we'll know that we went the long way. So BDA is a major arc because it's more than halfway. Okay, next is central angle. A central angle is an angle that has its vertex at the center of the circle. Central angle is an angle that has its vertex at the center of the circle. So here's the center of this circle. And then I can draw an angle there. I'm going to call that point O. So there's other angles in the circle. You could draw an angle here, but that wouldn't be a central angle because the vertex isn't at the center. So this angle, whose vertex happens to be at the center, is called a central angle. So in the picture, an example is angle AOD. Is a central angle. Okay, and then last but not least, the measure of an arc. The measure of an arc is the same as the measure of the corresponding central angle. The measure of an arc is the same as the measure of the corresponding central angle. So if I came over here and used my protractor to measure this, looks like maybe it's about 100 degrees. So this angle is 100 degrees. And now then we could look at this arc here that goes with it. So see how arc AD goes with that angle? Then the measure of that arc is also 100 degrees. So the way we write that down is we say the measure of the arc is 100. So the M stands for measure. Those symbols stand for the arc. So we're saying the measure of the arc is 100. Okay, so that's it for no cards. Let me pass out the hole punch for you. So the title of the paper is Circles, Circumference, and Area. Title is Circles, Circumference, and Area. And we're going to look at number 9 first. Don't have to draw this picture. Okay, so there's a circle in number 9, not surprisingly, because that's our topic, circles. And the directions are saying find the circumference and the area. So what formula do I use to figure out the circumference? Yeah?
2 times the radius.
Close.
The radius times
Circumference is
circumference is, sorry, 2 times pi times radius.
Good. So the pi is very important. Good. Because 2 times the radius would just be the diameter. But 2 times pi times the radius is the circumference. Awesome. Okay, so there's the formula we're going to use to find the circumference. And in the picture, they didn't give us the radius. So we have a little bit of work to do to find out the radius before we can plug into this formula. But that's our final goal, is to figure out what the circumference is. Okay, so they did give us this measurement, and they did draw a triangle in here. And they gave us that this angle up here is 30. So what's this angle down here? 60, right? Because the 3 angles of a triangle have to add up to 180. So this angle is 60. So this is a 30, 60, 90 triangle. So we can use what we know about 30, 60, 90 triangles to figure stuff out. So how does the hypotenuse relate to the leg in the 30, 60, 90? Yeah, Karen?
It's the short leg times 2.
Good, it's just double the leg. So that means in this picture, this length is 14. And then, of course, the radius is half of that. So in this picture, these two radiuses, the radii are 7. Okay, so it turns out that the radius is 7 as well. So now we can use that radius to plug into here to figure out the circumference. So you take 2 times pi times the radius. And then this is 3 numbers multiplied in a row. And when you have 3 numbers multiplied in a row, you can choose to multiply them in any order you want. So right now it's saying take 2 times pi first, but I'm going to take 2 times 7 first, because that part's easier. So 2 times 7 comes out to 14, but then I still have to multiply by pi later. So far what I've got is 14 times pi. All right, now I could go ahead and multiply by pi, but the problem is pi goes on forever. And so if I multiply by pi, I'm going to get a decimal that goes on forever. And I could write down some of those digits, but if I did that, I'd be rounding. In other words, I'm not getting the exact right answer if I do that. So if I want the exact right answer, this is what I'm stuck with, 14 pi. And in math class, we like to have the exact answer. So that's where we're going to stop. Okay, now when you measure circumference, what would the label be? Would it be cubic meters, or this is in meters? So if you're measuring how far around it is, what would it be? Square meters, cubic meters, regular meters? When you measure distance, yeah. It's just regular meters, because we're just measuring distance, right? Circumference is the distance around. So that would be regular meters. Okay, now the directions also say to get the rounded answer. So I am going to multiply 14 times pi, but I also wanted to emphasize this is the exact answer. So if the question says find the exact answer, stop here. But we could round as well. So someone with a calculator, tell me what you're getting for that. Yeah, Jennifer.
43.98.
Thank you. So we've had this discussion before. This number is convenient because you can tell what it is. It's about 44 centimeters all the way around the circle. But it's not exactly right. So this number is better because it's exactly right. But this number is better because you can tell what it is. So there's advantages and disadvantages to both. So that's why we're putting both down. Okay, then this question also says find the area. And the area formula is pi r squared. So that's going to be pi times 7 squared. And 7 squared is 49. So the area is 49 pi. Now, when you're finding area, you're figuring out how much space there is inside the circle. So you're counting the number of squares that would fit in there. That's what area is, counting 1, 2, 3, 4, 5, 6, 7, counting how many squares would fit in there. And so what we're counting are squares, and so that means that the label is going to be squares. And a square meter means it's a meter on every side of the square. A meter, a meter, a meter, a meter. So this is the exact answer, because we didn't round. And some problems ask for the exact answer, so you need to know what that is. But also, if you tell somebody, well, the area is 49 pi, you can't really tell what number that is. So it's also good to get a rounded answer. So go ahead and take 49 times pi. What do you got, Charlie?
153.94 centimeters.
Thank you. Two things wrong. It's meters,
Oh, this is-
and it's also square meters. Because,
Square.
yeah, because when you're finding area, you're counting how many squares there are in there,
Okay.
not how many lines there are. A meter is just a line.
Okay.
Good. All right, moving on to number 10. Not surprising, there's another circle there. And there's a square inside the circle. So all the angles are 90. And the side is 20. So all the sides are 20. And we're still trying to find the area and the circumference. Yes, I'm sorry, you had a question on this one?
Yeah, is that supposed to be centimeters at the bottom?
Yes, it's not. Thank you very much. Appreciate it. Yeah, that's what messed you up on that one. Sorry about that, Charlie. For some reason, I changed it to centimeters. It's the same measurement. Thank you. Appreciate it. All right, so looking back at this one, we're trying to find the circumference and the area again. In order to find the circumference and the area, we need the radius. And they didn't directly tell us the radius. So here's the radius. And I'm just going to go ahead and draw in the diameter as well. Okay, so then I'm going to look at that triangle there. And that triangle has a 90-degree angle, and it has two equal sides. So it's an isosceles triangle. And when you have an isosceles triangle, the two angles are equal. So what are these angles? Yeah, 45, right? Because 45 plus 45 plus 90 adds up to 180. So that means this triangle here is a 45, 45, 90. And the way you get the hypotenuse on a 45, 45, 90 is you take the leg and multiply it by root 2. So this is 20 root 2. And then the radius is half of that, so the radius is 10 root 2. So on both of these problems, circumference and area, those formulas are not too bad. You've seen them before. But we're trying to figure out what the radius is first before we can plug it into the formula. All right, so circumference equals 2 times pi times radius. So it's 2 times pi times 10 root 2. And then I'll go ahead and take the 2 times the 10. So that would be 20 times pi times root 2. And if we want the exact answer, that's what we're stuck with. Because root 2 is a nasty number that goes on forever. And pi is a number that goes on forever. So we can't go any further if we're going to have the exact right answer. So that would be meters again. That's 20 meters, so this is meters. But then if you wanted the rounded answer, you could go ahead and type in 20 times pi times root 2. So I didn't bring my calculator up, so if somebody could get that for me. All right, thank you.
88.86 meters squared.
Just meters.
Just meters.
Because when you're measuring circumference, you're measuring how many lines would fit around the outer edge.
Okay.
So it's straight lines that you're measuring for meters, the distance, as opposed to the area, which is how many squares there are. Good. Then the area is pi times radius squared. Radius was 10 root 2. So then you square the 10, and that gives you 100. And you square the root 2, and that gives you 2. So that comes out to 200 pi. And that would be square meters. And if you rounded that, it would come out to about 628. Check me on that, though. I think I just did it in my head, which is tricky.
Yeah, well,
You want to give me more decimals?
yeah,
Okay.
628.32 meters squared.
All right. Thank you. All right. Last one, number 11. There's another picture of a circle, not surprisingly, because that's what this new unit is about. And there is a triangle inside the circle, so it's kind of connecting last unit with this unit, and we're given just that the perimeter of the triangle is 60 times square root 3. So that means all the way around the triangle is 60 root 3. Oh, and the other piece of information is this is an equilateral triangle. So that means all three sides are equal. Okay, so if all three sides are equal, that means one side is going to be 20 root 3. Because if you take 20 root 3 plus 20 root 3 plus 20 root 3, you get 60 root 3. So this side is 20 root 3, this side is 20 root 3, this side is 20 root 3. Okay, but if I'm going to figure out the circumference, I need the radius. So let me draw the radius in. And let me draw another radius in. Okay, now, since all three of these angles are equal, that means each of them are 60. So that was 60, that was 60, that was 60. And that means that this just got cut in half, so this is 30. Then if you draw this line in, that makes a 90. So I drew all those lines in, and now I have a 30, 60, 90. All right, so the reason that's important is this used to be 20 root 3. So that makes this 10 root 3. Because I just cut it in half when I drew that line in. So on a 30, 60, 90, the long leg is 10 root 3, which means this is going to be 10. And then this is the hypotenuse. How does the hypotenuse compare to the short leg on a 30, 60, 90? It's double. So that means this is 20. So I did all that work just to figure out that the radius is 20. If I drew a bunch of lines in, then I got a 30, 60, 90, and then I could figure out what that was. Okay, so R is 20. And then you can finish that one on your own now that I know that R is 20. Just take 2 times pi times R to get the circumference, and pi R squared to get the radius. Okay, so last unit was about triangles, and then this unit is about circles. That's why we had so much circle vocabulary today.